Okay, and yeah, sorry about that.
Okay.
Yeah, so yeah, what you have now is sin c equals 1 over square root 2, then solve for c, you get pi by 4. Oh, this one okay, right?
Yeah, okay.
I know I'm going quite fast, so you can watch the video recording again. Let me know if you're confused.
Okay.
X-axis, y-axis, this is y equals sin x. Okay, let's move on. Next question, 1b. Okay, I need to bring up the question again. Let's take a look at question 1b. So a large fishing pond has an initial fish population of 6 million. So straight away we can conclude that T is equals to 0 and P is equal to 6. Right? Why is it 6, not 6 million? Because later on in the question they told us P is in millions. So just 6. Okay, it is found that the annual growth rate of the fish population is 5% of the fish population P at time T in years, and K% of the annual fish population is lost due to fishing activity, where K is a positive constant. Show it's this equation. Okay, so straight away you should realize that natural growth rate here is just referring to dP by dt, but more like the rate in. dP by dt should always be equals to what? Rate in minus rate out, correct?
Yeah.
But what's my rate in?
5%.
5%. So is it just 0.05?
0.05 times P.
Yes, because you see the keyword off, it's like primary school style. You see off, then you think of times. Usually, not always. Okay, at time T. Then after that, K% is lost due to fishing activity.
K divided by 100 times P.
Yes, that's your rate out. K divided by 100. K% multiplied by P. But it's a minus in front. Then you realize that you can just factorize the P out, then you get this fraction. Okay? Yeah. Okay. And then after that, you want to find out what's the value, find the value of K and find out when the fish population will double after 50 years. I'll go back to that later. So let's just write down. Okay, wait a minute. I should just copy down the question now. Sorry. Let me try that. Okay, where's my question? It's over here. Okay, there we go. Yeah, so part B is over here. Let's just take a look. Yeah, rate in minus rate out. I just written it out. Simplify, and eventually I get to the answer. This part okay?
Yeah, can.
Okay, can. Yeah, I just gave an example how do you convert from 5% to a fraction. Okay, then next part we're gonna try to solve for P now. The working goes in this order. So let's just look at this first. So how do you solve for P? dP by dt is equal to 5 minus K times P over 100. So straight away you must notice K here is a constant, not variable, just a number. And P here is a variable, P here is a variable. So this is a separable differential equation. What do you need to do?
Let's bring the P over 100 over.
Yes. Actually, I think what you usually do is you just bring everything over. Right?
Yeah.
Or sometimes you bring the entire fraction over, so flip it around. But actually, all you need is to bring the dependent variable over. Okay, so here what I did is I decided to bring the P over, so it becomes 1 over P. What am I left behind? 5 minus K over 100. This is perfectly fine because it's just a constant. Very easy to integrate. Integrate constant, you just get constant times T. Can you see?
Yeah. Okay.
And also take note that it's T, because independent variable here is T, not X. Not X. Okay, then of course, integrating 1 over P, you get ln of modulus P. Don't forget the plus C. Okay? This part okay? Okay, good. Then now I skipped a few steps. ln I bring over. Oh, by the way, your ln, you can only, let's say ln of P equals to 5 minus K over 100 times T plus C. You want to do the trick where the ln bring over, it becomes an E, right? It only works when there is a single ln. Single. So if, for example, let's say quick example, you had ln modulus x minus away ln x plus 1 equals to, I don't know, for example, 5t plus c. How do you make x the subject?
Becomes ln x over x plus 1.
But you must have what? X over x plus 1, what's missing?
The modulus.
Modulus sign, okay? Equals to it plus c, nothing happened. So now, how do you continue?
Now I can do the e already.
Correct, yes.
Yeah.
So x over x plus 1, the modulus still there. We do it step by step. You can essentially bring the ln over, then you get e to the 5t plus c. Okay? Okay, good. Then after that, you continue simplifying it as e power c times e power 5t. Right? Then after that, x over x plus 1. You remove modulus. What do you need to introduce?
The plus minus.
The plus minus, exactly. So now you will be able to obtain plus minus e power c times e power 5t, which is a constant. This is a constant. What do you replace it with? Letter A. It can be any other letter you like. A times e power 5t. Then now you just have to make x the subject. No space. Let me just squeeze somewhere here. Then how do you make x the subject? You think of it like this. X over x plus 1 is now equal to something. What do you need to do? Cross multiply, right? Go over. So we are left with x equals to a e power 5t multiplied by x plus 1. Times it out. You get ae 5t times x plus ae 5t. A times e to the power of 5t. Then you see x on the left, you see x on the right. This one is a non-x. So leave the non-x alone, bring the x over. So I can get something like x minus away a times e power 5t times x equals to ae power 5t. What do you do? How do you solve for x?
I factorize out the x.
Then you're left with what exactly? 1 minus ae power 5t equals to ae power 5t. Solving for x.
I bring over the 1 minus ae. You can't divide.
Very good. So ae power 5t divided. Okay, so you know this, right? Okay, so I checked your differential equation homework. You can do most of the questions, It's just that you get tripped up by the differentiation.
Oh, yeah.
When there's a substitution.
Yeah, I need to do more practice.
Yeah. But you got the method. You know what's going on. Oh, okay. Back to the actual question. So, where was I? Yes, you same thing here. It's just that the coefficient got a little bit bigger. ln is a single ln, so good. We can directly bring over. You get e to the power of all this plus c. But I skip a step. I just immediately rewrite as times e power c. Okay. Then after that, you bring the e power c in front because it looks nicer. And then the modulus p you open up. So it means you introduce a plus minus, which means that you have a plus minus e power c as a constant multiplied by e power whatever. The t is a variable, so you leave the e power something t alone. You focus only on the plus minus e power c. You replace it with an a. Then after that, how do you solve for a? How do you solve for k?
I start in the initial thing.
Yes, correct. Sub in the initial condition. So let's take a look. Here they tell you t equals 0, p equals 6. Oh yeah, by the way, here you should notice that there are two unknown constants. Okay, two unknown constants, namely a and k. So how many initial pairs of initial conditions do you need?
2?
Yes, exactly. Which means that you need two initial conditions. Here, let's read the question now. What is the first initial condition they gave us? It's this one. T equals 0, p equals 6. Right? This is the first. But what's the second one? So for here. What does it mean when they say fish population will double? P equals? At first it was P equal to 6.
Oh, 12.
Exactly, yes. So you must guess this from the story on your own. No, they will only present it in terms of English. They are testing you on your ability to translate from the English to the math. Okay. How about 50 years? What equals what?
P equals to 50.
Exactly. Then that's your second pair of initial condition. They will not tell you directly. You have to deduce on your own. Is this part okay?
Yeah.
Not too bad. Okay, can. So yeah, let's just sub in the initial condition. So first one, T equals 0, P equals 6 million. 6, don't need the million. So you get 6 equal to A times E power 0. You know how I got 0 here?
Yeah.
So any constant multiplied by our 0 is just 0. Then E power 0 is what?
1.
Exactly. So you just have to have A times 1, which means I'm just left with A. Then A equals, I'm just left with A equals to 6. Okay, good. So that's A equal to 6, but now we want to sub the 6 back inside, and then we will get P equals to 6 times E power 5 minus K over 100 times T. And I label it equation 1. Still got unknown K, then how?
Sub again.
Exactly, that's all. Correct. Just sub again, which is what I've written over here. To double the fish population. Oh my goodness, there's a collision. Wait, let me up it down. Okay, better. What was I saying? Yes, which is read the English and then you find out the new initial condition. To double fish population, P will just be 12, right? 2 times of 6. And T, they told us, is 50 years, so 50. Then you want to substitute P equals to 12 and T equals to 50 into equation 1. What will you get? 12 equals to everything else, just replace the T with a 50 and P with 12. Can? Okay, then after that, you can just solve. So let's just go through step by step. 12 and 6 multiplied by E power whatever. How do you get rid of the 6? You bring over. So it's just 12 over 6, which is 2. Okay, I simplify in my head into 2 straight away. Okay, so now, I just realized something. I forgot. Oh, wait, no, I didn't forget. I was doing things in my head. Here, there's a over 100. Here has a times 50, which means they'll cancel off to become a 2. I thought I forgot to write a 50. No. Actually, they cancel off. Oh, yeah. Okay, then after that, you want to make the power the subject. So you have to chop off the base. What do you need to do? You take ln. So ln 2 equals to the power. This part okay? Logarithm? Can. Okay, then after that, you got divide by 2. So how do you get rid of it? Just times 2 over. So 2 ln 2 equals to the power, the numerator 5 minus k. Can? Then just solve for k. The minus k bring over the 2 ln to the 2 ln 2. So 2 ln 2 plus k equals to 5. You want to make k the subject. So 2 ln 2 have to bring over now. So it becomes minus 2 ln 2. Of course, 2 can bring it on top. If you remember, like m times ln x is equal to ln of x to the power of m. Remember this rule?
Yeah.
You remember your logarithm rules, right?
Yeah, should be.
Can I? Okay, good. Then I won't talk about it. 2 go up, then it becomes 2 power 2, which is 4. So 5 minus 1, 4. Done. Easy?
Okay, can do.
Yeah, can. All right, let's go to the next question. So question 2a. Let's see, by means of a substitution y equals to z times x, show that the differential equation, this fella here, can be reduced into dz by dx equals 18z times 8 minus z. Let's just copy down the a first. Do you want to try this? Take out a piece of paper and pen and try.
Okay.
Let me just show you the question first. You have the question? Oh, I am revealing the answer. Oh no. Just I think I sent you. It's differential equation number 1. You can open the PDF if you need.
Oh, okay.
May I know what have you done so far?
Like I differentiate both sides of the substitution.
Okay, good. Did you get this? Z plus x times dz by dx. Okay, pause now. Let me give you some hints. Here, let's straight away, right? Before you proceed further, please take a look at your differential equation now. Can you what you should write down is given ... then you copy down this equation. Then can you tell me your answer to the derivative of this substitution compared with this one? Which is the most striking thing that looks the same to you?
Oh, the dy dx.
Okay, but over here, in front of dy dx is a what?
X.
Multiply by x more specifically. So what do you think you should do to your resulting derivative?
Try to like multiply x.
Exactly. So you multiply by x on both sides.
Oh.
That will be easier. Okay.
Oh, okay.
And carry on. Can't see what you're doing. This is a bit confusing. Okay, maybe I'll give you 1 more minute, then you take a photo and send me.
Oh, okay, sure.
If you're done sooner, then just send only. Is everything okay?
If it becomes even longer than like shorter, then I can use.
Okay, take a photo and send. Take a photo and send. I'll give you some hints first.
Okay.
I think you're probably on the wrong track already. You bring you back. Okay, let's take a look. Okay, you multiply. Okay, what did you do? Dy by dx equals z plus x times dz by dx. That is correct. So, what did you do? Okay, so you multiply by x, so you get zx plus x squared times dz by dx. That's good. That's good. So, what did you do next? Or you substitute the left-hand side of the given equation, x times dy by dx, with the zx plus x squared times dz by dx. Okay, good. So it's equal to y bracket 1 plus x minus 1/8 y, 1 over 8 times y. Okay, then what do you do next? You substitute y with zx. So, okay, you get 1 over 8 zx. All right. Continuing on, you brought the, what did you do? Let me see. You minus zx on both sides, okay? And then you times the y in, so you get y. Oh, but you immediately substitute y with zx. Okay. correct. Then zx times 1 plus x minus 1/8 zx bracket minus zx. Can. Then you divide by x squared. Can. But then, does it work? Yes, it does. Yes, it does. Carry on. Just a hint for you is minus 1/8 zx minus zx. It's just minus 1/8 minus 1. So it's minus 9/8 zx.
Oh, okay.
Combine like terms. Might have been a bit simpler if you did not substitute the y, because you can solve the y straight away. If you notice a pattern, like if you didn't substitute the y with zx, you could have just cancel off a y on both sides. But never mind, you're on the right track. It's okay, continue. Just more long-winded. Did you get it?
No, like now I got a quadratic equation.
Wait, what? Okay, let me just. Okay, I'm gonna save some time. I'm gonna copy down what you've written so far. If I never check it wrongly, it should be okay. All right, can you see the pink color writing?
Yes.
Oh, you sent me a new photo?
Yeah.
Okay, let me see. Yeah. Okay, so you updated it to be minus 9/8, correct? Yes, this part becomes minus 9/8 zx. On my iPad, I'm writing already, minus 9/8 zx. And then after that, you continue by distributing the zx. Going. Oh, that's not a good idea. That's not a good idea because this is already factored form, right? You notice our x squared at the bottom. You notice that there's a times x at the top.
Oh no, yeah. Oh.
So you can have cancel it straight away to be faster. Oh.
Okay.
So okay, never mind, but your working is fine. Zx times 1 zx times x zx squared, zx times negative 9/8 zx, you get negative 9/8 z squared over x squared. Okay, good. Then you cancel one copy of x, so you get z plus zx minus 9/8 z squared x over x. Can. Then you're on the right track actually. So continue. What happens when you got a plus b plus c over d? You can always split up as a over d plus b over d plus c over d. Oh, so you split it up. Anything to cancel? Yes, got many x's that can cancel off. But something special, what's z over x? Y equals to z times x. So z over x is what? Oh wait, actually z over x, you should leave it alone. Let's just continue with, I mean, copy down. So what you have now is 9/8 z square x plus z times x plus z divided by x. What I'm suggesting to you is you can now split it up. So over x, over x, over x. Then they can cancel off one copy of x, one copy of x. Z over x, let's leave it alone. Negative 9/8 z square plus z over x. Actually, I'm a little bit confused. How did you get a z over x? Okay, let me just double check your work again. Sorry.
Okay.
Live. Okay, so you differentiate with respect to x first. Okay. Correct. C plus x times dz by dx multiplied by x on both cx plus x squared dz by dx. Substitute the left hand side, you get this. Okay, equals to this. 1 plus x minus 1 over 8y. Then you substitute the y with zx, you multiply out everything, you get dx times 1. Okay, can. Oh, ayah. I see the mistake. Okay, wait. Let me you share. Can you see my chat screen?
Yeah, can.
Here, close bracket on the left.
Oh.
Here, the bracket suddenly moved to the right, including the minus zx. You absorb the minus zx inside the bracket.
Oh.
Wrong.
Oh, I see. Yeah.
That should have been here. The zx is left alone. And sorry, the zx shouldn't be left alone because the zx over there, because you're putting it on top of a x square fraction, so it should actually be where's my pen? I cannot find this one. This one should actually become zx cubed already. Right? Because you wow, this is so bad handwriting. Because you're adding you're converting zx into zx cubed over x squared before you add them together. Right?
Yeah.
So it's algebra again. Oh, algebra.
Oh, no.
Always algebra for you. Yeah. So, anyways, what we should do to be smart is to actually not combine the zx onto the fraction. Instead, what you should do is to, sorry, can you give me like 30 seconds?
Okay.
Plug this in and then I can start writing neatly. Okay, save some time. So as I write, I hope you're taking notes as well. So let's just go. So yes, this part here, the bracket should actually be over here. So the zx, I recommend that you don't bring it on top onto the fraction. Instead, you just leave it outside, minus zx. Oh, minus zx. Why? Why? Because 等一下 sorry. I'm the one who's blur. Oh my goodness. No. It should stay on the numerator. Don't need zx cubed. Yes, correct. The x square you bring over to the entire thing. So don't need x cubed. I'm so sorry. Yeah. The minus zx is fine. This is fine. Just make sure the bracket change only. Okay, then what you will get if you expand? You won't get the 9 over 8 zx. No. It will still be the minus 1 over 8, but at minus zx at the back. Okay, maybe it's better if I just rewrite the whole thing. Getting a bit messy. Okay, let me do that. Oh boy. Let's go. Let me copy down what you have so far. Oh, by the way, also advice. Got one of the comments I made on your homework. Please cue some tree.
Oh, okay.
Not literally. I mean, use a bit more paper so that you can see what's going on more clearly and not get yourself confused.
Oh, okay.
Okay, let me just share my screen now with the iPad. So this is what you, I need to share like this. So this pink color one is what you've written in one of the steps, that's correct. So when you bring the x square over, you see your dz by dx, just weigh some paper. Don't bother writing it as dz by dx. If not, you get confused.
Oh, okay.
Then just save some paper. And you don't have to squeeze everything in between two lines. You can always make your font size bigger.
Oh, okay.
Always make the font size bigger. Then after that, you want to make dz by dx a subject. So yeah, I copy and paste. Then maybe if you're very, very confused, you can bring on top a little bit. Then this one, bring it below to make it look more like a nice fraction. Okay, can. And also at this stage, right, multiply, I think you know what to do, just that you missed out the bracket. You put the bracket in the wrong position. I don't know. Just be more careful next time. Distributing zx times 1, you get zx. Zx times x, you get zx squared. Minus 1 over 8 times z square x squared. Then minus zx. This part okay?
Yeah.
What's missing?
The x squared.
At the bottom, exactly. Good. So anything to cancel? Yes. Zx minus zx. Then we continue. So now what we have is something minus a second thing divided by x squared. I can split it up into zx squared over x squared minus away 1 over 8z squared x squared over x squared. Anything to cancel? Yes. X squared, x squared. Second fraction?
Oh, also the
yes. X squared, x squared. Okay, so just be careful of this bracket. It's always your algebra that has an error that prevents you from solving.
Oh, yeah.
Just be careful. Then z minus 1 over 8z squared. Last step, factor. Factor out 1 over 8z. Means that this will become 8, right? Minus away z. Done. And okay, good. So that's also what I got. I showed a different way where I did not substitute the y with whatever zx. I just cancel off the y straight away.
Oh.
Okay, yeah, then my working is a little bit shorter and simpler. You can go and take a look, but anyways, you'll get back to the same answer. Your method works. Your method works. Okay, carrying on, now we want to have, we have dz by dx equal 1 over 8z times 8 minus z. We want to solve for z. How? Separable or normal? This kind of equation?
Oh, this one is separate.
Separable one, definitely. This is like a stupid question. Definitely should be separable. This one, the whole point of differential equations is to test you on separable. Guaranteed in A levels we'll have one question come out on differential equations. It's usually separable. So you have to divide over. That's your first step. Here, I did not choose to divide the entire 1 over 8 over. Instead, I divided by only the variable part. Can you see?
Yeah.
Yeah, good. By the way, if you want to divide everything over, maybe it will be smarter if you rewrite it as an entire fraction. I'm scared of your algebra. I'm afraid that you'll get wrong. So let's say that you rewritten it as one entire fraction already. If you want to bring the entire thing over, this will mean you get 8 over z times 8 minus z. Then you multiply by dz by dx equals to 1. This part okay? Yeah, flip the fraction around. Okay, if you're not confused by this, then you can also carry on with this one, but I will continue with my simpler version where the numerator is just a 1. I left my 1 over 8 on the right hand side. Continuing on, dx cancel off. Now you're integrating a product of linear factors at the denominator. What should you do? Partial fractions, right? Right, so that's what I did here. 1 over z times 8 minus z equals a over z plus b over 8 minus z. So multiplying by z over 8 minus z times 8 minus z on both sides of the equation, I get 1 equals to a times 8 minus z. The z will cancel off with the denominator. Likewise, over here is b times z. This part okay, right?
Yeah, it's okay.
Okay, and then sub z equals 8, sub z equals 0. I will solve. I will get b equals 1 over 8 and a equals 1 over 8. Okay? Okay, good. So that means I can replace my fraction with this two, a sum of partial fractions. Then you try to integrate partial fractions. This is easy because straight away I notice there's a 1 over 8 I can factor out first. 1 over 8 factor out first. That's why I have round brackets here. Then I integrate each term. 1 over z becomes ln modulus z. 1 over 8 minus z becomes ln modulus 8 minus z. But be careful, there is chain rule. Here, do you see I noticed you make this mistake in your in your homework, you forgot about this. Here, minus z. The variable is z. There's an invisible -1 here. Do you know that?
Yeah.
So you have to divide by -1. You didn't do that in your homework. Okay? Please be careful. Actually, is my audio okay?
Yeah, okay.
And I changed my microphone a little bit. Yeah. So -1. Make sure you have. Don't have the whole question gone. Yeah. Then 1/8 in addition to your algebra mistakes. Integrate, and what do you get? 1/8x. Take note, why is it an x? Because I'm following the letter. The independent variable. Where did the x come from? It came from here. The independent variable. The bottom one. So independent. That one is dependent. Okay, take note. It doesn't always have to be x. Sometimes it's t. To be a t. Depends on the question. If we started off with dz by dt, then this you expect it to be a t. But here is a dz by dx, so this is a x. Carrying on, we get 1/8 in front, can multiply in front, multiply to the right, so we get x plus 8c. Then you have 2 ln already. Can you e straight away? Can you e straight away? So conclude z minus modulus 8 minus z equals to e power x plus 8c. Can you do that?
Okay, no.
Cannot, this is wrong. No, must have a single ln. So you need to use your logarithm rules. Minus becomes a fraction, and with modulus. So you can make it into a single ln, then you can bring it over to become e power x plus 8c. Split it up, e power 8c, e power x, multiplication, multiply. But then you open up the modulus, you get plus minus. I'm doing everything in one step. Is that okay?
Yeah.
Okay, then after that, this constant replace with a. So now you want to make z the subject. How? Cross multiply. Denominator go over a minus z, then multiply out. So 8aex minus a times e power x times z. Just bring the minus something with z over, so you get plus aex times z equals to 8a e power x. Factor out the z, you get z times 1 plus ae power x equals to 8a e power x. Then you just have to divide by this fellow. Where's my fraction? Oh, it's here. Go to the bottom, and then you will get your z. But wait, we're not done yet, because the question, they actually asked for what? Remember? You got the PDF open?
I got open it.
Just open on your Acrobat or something. Sorry,
they asked for y in terms of x.
Exactly. So that's why the last step is to replace the z with y over x. Maybe I write down a reason. Because question asked for y. Question asked for y. Here, I have highlighted my x in pink color to remind you that you're trying to solve for y. So what do you do with the x? Times over, which means that it appears on the numerator. Right? Oh yeah, by the way, I don't know if you've seen that what do you call that? What was I saying? What do you call it? The correction. But here, let's say you got a fraction like this. Tell me, is it okay for me to cancel 16 and 2? So become 1 and 8?
I think I did that.
Can or not?
Now you ask me, then confirm cannot.
Yes. So I hope you know this is definitely not correct. You can just double check. The actual way to do this is x over 16 equals 2 over x. You need to cross multiply. Remember? You never cancel across a fraction. This one a very fatal mistake. Wow, I'm very scared when I see it.
I do that for every question.
Oh my god. Okay. Then you must go and check again, I guess. Yeah. I checked through all your questions already. I hope I cut all my mistakes. Yeah, so what you get is x squared equals 32. Then after that, you take square root, plus minus square root. Okay, I'll just simplify a bit more. So 16 times 2, which means that you can split it up into square root 16 square root 2. This part okay, right? So square root 16 is a 4. So here, if you got x over 8 equal to x 1 over x, what you will get now is cross multiply x squared equal to 1 times 8. I put question mark there. Then x equals to plus minus square root 8, which is 4 times 2, so square root 4 square root 2, plus minus 2 root 2. Okay? How can you get two different answers to the same question? How do you check whether your answer is correct or wrong? You always go back to your original equation. You take your x, sub in. So let's say we take the wrong answer. Check that it's wrong. You see, let's say we only check the positive root to save some time. 2 over square root 2 over 16 should be equal to 2 over 2 square root 2. This is left hand side and right hand side. You check, are they the same or not?
Oh no.
No, they are not equal, so therefore the answer is wrong. So the conclusion is no, you cannot cancel across a fraction. Okay? You got equal sign, it's like a river. You must separating the two regions. You cannot interact. The only thing that you can cancel are within a fraction. So let's say, for example, I don't know, x over 2x over, I don't know, 14 equals to 7 over x. Can you cancel the 14 and 7?
Cannot.
It become a 1 and 2?
Cannot.
Cannot, no. How do I write notes for this? Maybe I'll just start with the original here, and then I'll duplicate it, and then I'll purposely cancel, and then I'll box it up and say no. Okay, the correct way to do it is cancel within a fraction. You see 2 and 14, and this one becomes 1, this one becomes 7. Then you get x over 7 equals 7 over x. For the coincidence that they look almost the same, you can cross multiply. X squared equals to 7 squared. Right?
Okay.
Then after that you solve. So x equals to plus minus 7. Okay, can
Okay.
no cancelling across the equation. Okay.
Okay.
Yeah, good. Then after that you get this x times over. Okay, that is good. That is part A. Now let's move on to part B. Question 2b is a certain species of bird with a population of size n,000 at time t months satisfies the differential equation d2n by dt square equals to e to the power of -1/4 t. Oops, let me just copy down the equation first. This one is an easier question. You don't need to come up with the equation on your own. They just want you to integrate. So how do you deal with a second derivative? You just have to integrate how many times?
2 times.
Exactly. Let's integrate the first time. What do we get? You get back to dn by dt, right? So you just have to integrate the right hand side. Integrating, okay, whenever it's a linear factor, we are lucky. It's easy to integrate. All we need to do is to copy down the exact same thing, then divide by the coefficient. So divide by -1/4, so multiplying by 1 over. Right, we want to put the 1 over in front. Yeah, maybe I'll just put that down. Okay. But if you don't have space, then you can just work it out at the side. What is the 1 over -1/4? 1 over 1 over means you flip the fraction. Okay, sorry. I mean 1 over means you have to flip the fraction. So flip it and you get -4. Agree?
Oh, I always thought it's just copy the -1 over 4.
Wait, did I do wrongly? I don't. 1 over -1/4 means 1 divided by -1/4. Keep, change, flip. Do you know? Primary school, KCF. Keep the 1, change the divide into times, flip the fraction. So you get -4/1.
Oh,
-4.
I think I integrate wrongly in one of the questions. Okay, later I can check.
Oh, okay.
Because
okay.
I thought it's just copy the -1/4 as the new coefficient.
No. It's always 1 over. 1 over.
Oh,
Okay.
no.
Okay. Right. Let's just do a simpler example. If it's a whole number, integrate e to the power of 3x dx. What do you get? Copy, but you divide 1 over 3. All right.
Okay.
Right. Differentiate, then you can get back. Here they trick you out, not a whole number. Here it's like a 1 over 4 or 1 over 3. So kind of deal. Okay. Okay, carry on. Let's just move on. So now that you got a c, we're not done yet. We still need to find n. From dn to dt, integrate again. So integrate -4e to the -1/4 t plus c. Don't forget the plus c. you need to integrate plus c. So let's see. Here I'm going to integrate the first term. I'll factor out my -4 first. Integrating e power -1/4 t. Oh, it's the same this answer just now. So I'll just copy and paste because I'm lazy. Copy paste. Right? Plus integrate c. So now you get c times c. But you need another constant. So choose the next letter in the alphabet, d. Arbitrary constant. Can? Okay, good. Then simplify a bit more. So positive 16 e power -1/4 t plus ct plus d. Okay, this is n. We're not done yet. You still need to solve for c, solve for d. How do you do that? You need to sub in initial conditions. Oh, let me see. Yeah, they gave you n equals to 30, t equals to 0. Take note that the part of the question, sorry, where they ask you to sketch 3 members of the family of solution curves, right? It's no longer in your syllabus. Okay, so let's just solve by subbing in the initial condition. So n equals 30 when t equals 0. So 30 will be equals to 16 times e to the power of 0 plus c times 0 plus d. Anything power 0 is just 1. 16 times 1 is 16 plus times 0 is just 0. So plus d. Times 0 is 0 plus 0 means you can essentially throw away. So solving, you get d equals to 14.
Okay.
But there's not enough information for us to solve for c. Because you see there are 2 variables, you will need 2 initial conditions. Here they only gave us 1. So that's all we can do. Okay. Therefore, we get n equals to 16 times e to the -1/4 t plus c times t plus 14. Last time in the old syllabus, when you want to sketch family of solution curves, this is expected. When you got an unknown c, you just plug in different values of c. So I like to pick -1, 0, and 1. Then you draw the graph for each value of c.
Oh.
Very simple, just use GC only. But they remove from the syllabus, I also don't know why. But anyways, that's the answer. We can't go further because it's not in the syllabus anymore. So let's move on. This is now question 3, I think. Okay, let's take a look at question 3. So curve C has parametric equation x equals to u to the power of u. Wow, never see before. Okay, and you also know that y is equals to ln of u. What else? U is more than or equals to 1. So can you tell me, if u is more than or equal to 1, what can you tell about u to the power of u? Is more than or equal to?
More than or equal to.
Not sure, right? Not sure, then you must use your GC. So let me just bring up my online GC if I can find it first. Shares. Okay, let me bring up my screen first. Hold on. Why is everything not cooperating? Oh my goodness. What is going on? Can see? Okay, so this is GC. Yeah, I can find it online now. Yeah, so what we're gonna do now. Okay, I'm just gonna make my calculator go a bit faster. Okay, clear. Go on. You want to draw a graph of u power u, but of course in this case the variable is x. So x power x. Let's draw a graph. Oh, by the way, hack for you, cheating. You see this x rest button? Change it to whenever the number is small, the quality of the graph is very good. But when the number is very big, right, the quality of the graph drops. So I like to go for lucky number 8 and draw the graph. Oh, zoom standard number 6. You'll notice that it will graph a little bit faster. Number 8 will go number 8 or number 10, you will give you a very low quality graph, but a lot faster. Okay, so main point I want to make here is that you see that the graph it starts off at where? Maybe I zoom box number 1. I hope I don't need to explain how to use zoom box, right? Yeah. Okay. So enter, go to right, go down, enter. Yeah, so you notice it goes down and then it goes up again. Oh, okay. Can let's just figure out some of the turning points. So let's say we want minimum. So number 3 for minimum. So we go a bit to the left of the minimum point, roughly. And then we go to the right. And then press enter. Then you solve. So you get this coordinates. Not so important. I'm just going to copy it down for you on my iPad screen, then we can move on. Oh. Yeah, you can also find out on your own GC. Okay. Change screen. Hold on a sec. Okay, good. So what we realize is that U power U from our result from our GC, we get a minimum point. Let me just draw a quick sketch of this. There's a minimum point, and the minimum value is 0.69220063. Okay, which occurs at U equals to 0.367882216. Okay, Ken, moving on, let's read the question. So what the question asks, parametric equation, blah, 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 show that dy by dx is equal to this. Okay, I hope you remember that dy by dx is almost like a fraction, So you can always divide by t on both sides. Agree?
Yeah.
Yes? Then what do? So what this means is you need to find dy by dt and dx by dt. Oh, sorry, the letter here is not t. I got 2 u's already. Because I memorize, I always do t by t, divide by t, divide by t. But actually, you must read the question. The letter they use is not t, but rather u. So change to letter u. Contextualize. Don't just maybe memorize. Memorize the correct thing. So dy by du. Let's figure out what's that. Differentiate y with respect to u. 1 over
1 over
u. Correct? Yes. Differentiation. Differentiate ln, you get 1 over u.
Correct.
Correct. Do you need modulus?
You need, because it's more than 1.
Correct. Yes. Okay. Then no, actually, whenever you differentiate, right, you don't need to put modulus. Never need to put modulus. It's not whether this one is more than or equal to 1. Because in order for this to even be defined in the first place, your u must already be more than 0. Yeah, but anyways, don't need modulus. Don't need modulus. That's the main point. So now, how about x equal to u power u? How do you find dx by du? Think about it. Let's simplify the question with normal variables. Y equal x power x. How do you find dy by dx?
Cannot differentiate on both sides.
So differentiate on the left. Then how do you differentiate x power x? We only teach you a power x. You differentiate.
Can ln both sides.
Yes, very good. Correct. So this one will become ln a then times a power x. Or the special case where a is a e, e power x will become just e power x, because you can think of it as ln e times e power x. Ln e is just 1, so it's just e power x. And the other case will be d by dx of x power constant. This is just power rule, learned before in Amax. But here, you see, these first 2 cases, right, the variable is on top, the constant below. This other case is variable at the bottom, constant on top. Can you see they're swapped around? Here, it's variable on both sides. There is no known standard way to differentiate this. The trick here is ln both sides, exactly. So ln y equals to ln x power x. That should be your first step. Then what happens? The x here, power rule.
Yeah.
Bring down. So x times ln x. Okay? I color code it. This one is the brown one. This one is the yellow one. Yellow one bring down. Okay, then we can do implicit differentiation. How do you differentiate ln y? Ln is 1 over y. But don't forget, because this is implicit differentiation, we need dy by dx. Okay? Then this one is a product, right? Product x times ln x. How do you differentiate?
By part.
By parts. Don't need. Product. You can just do Differentiation, that one is integration. Don't just remember by parts. Integration by parts. Now we're doing differentiation only. Very easy. Also, it's actually product rule.
Oh, yeah.
Pick the first guy, okay, differentiate the second guy, 1 over x. Plus or minus?
Plus.
Plus, take the second guy, ln x, differentiate the first guy. Take one, differentiate the other, plus take the other, differentiate one. Where am I? Where do you go? Sorry. Take one, differentiate the other, plus take the other, differentiate one. Okay, simplify. So x times 1 over x, you get a 1. Ln x times 1, ln x. You get 1 over y times dy by dx. What do we want at the end of the day? We actually want dy by dx. So we times y over. Times y over, we get y bracket 1 plus ln x. But wait a minute, what's y?
Oh, so sub in.
Sub in, exactly. So you get x power x times 1 plus ln x. Okay, so now I have done it in the conventional variables y and x. Here, when the variable changes to x and u, you just change accordingly. Also, the x becomes a u. So it becomes u power u bracket 1 plus ln u. Is that okay?
Oh, so I can do in the conventional, then I just start in like that, or cannot?
Yes, can.
Okay.
Let me show you how to do it in the non-conventional. So if I'll just do it quickly, since you already know this, x equals u power u. Take ln on both sides. Ln x equals to ln u power u. Bring down the power, you get u times ln u. Differentiate with respect to x. So now ln x becomes 1 over x. Oh, sorry. Differentiate with respect to u. Apologies. Here we are differentiating with respect to u being the independent variable. So what we get is 1 over x, but then implicit differentiation tells us that x is a function of u. So dx by du equals to product rule. Take one, differentiate the other, plus take the other, differentiate 1. Differentiate u, you get 1. Multiply u over u, you get a 1, plus ln u times 1 is ln u. Here you got 1 over x times dx by du. So now you can times the x over, so dx by du is equal to x bracket 1 plus ln u. What's x? Oh, x is here, u power u. U power u times 1 plus ln x. Sorry, ln u. Is that okay?
Yeah.
I'm just going through the same thing. I changed letter only. So not that bad. Then after that, here the u you can just multiply to the bottom. Multiply to the bottom. So you get 1 over u power u plus 1 bracket 1 plus ln x. Sorry, ln u. I keep saying the wrong thing. Can? This part okay, right? When you what you're essentially doing is you're multiplying by u over u. So 1 over u and u cancel off, but then you introduce your u at the bottom. So you can just add 1 to the power. This part okay, right?
Okay.
Okay, good. Continuing on. So we have shown. Hence deduce that c is an increasing function. Do you remember what's the rule about increasing, decreasing function? Increasing function means your dy by dx is?
More than 0.
Okay, I'm just gonna say is the same as. Yes, correct. More than 0. And of course, decreasing is less than 0. This is the only one that's relevant, so I'll just write this down. But how do we tell that this quantity here is more than 0? It's very silly, very silly. You just need to know from the graph. Just say that this guy is more than 0 from GC. That's all. Yeah.
Oh, okay.
Really. Then here, lnu may is actually more than or equals to 1. Okay, let me think a bit. Here the u is more than or equal to 1. Yes, correct. So more than or equal to, sorry, more than or equal to 0. Yes. Because since u is more than 1 or equals, right? Right now, you can use GC as well to verify. Can be equal, because if u is equal. But what do we have on the denominator? denominator, let's take a look. It's 1 plus ln Maybe it's smarter if I just copy down the derivative. Go over here. So what we have is the denominator, there's a 1 plus ln u. So let's figure out what's 1 plus ln u. Plus 1 on both sides is more than or equal to 0 plus
1.
1. So it's just a 1, which is obviously strictly more than 0. In other words, 1 plus ln u is strictly more than 0. Agree?
Yeah.
So now what we have, u times u plus 1 multiplied by 1 plus ln u. We know the first guy more than 0, second guy more than 0. Multiply together, it becomes more than 0. Yes, positive times positive gives you positive.
Yeah.
1 is also positive, right?
Yes.
So what happens when you take positive over positive?
Still positive.
Exactly, 1 more than 0. So therefore, 1 over u power u plus 1, bracket 1 plus ln u, which is positive over positive. This is not actual official working. You don't write it down. Then it becomes more than 0. Just conclude straight away. And then this is just dy by dx. And then because dy by dx is more than 0, this implies that y is increasing function. Okay? Yeah. Or C. C. All right. Can. Good. Let's move on. Part 2. No space. Wait. At a page, question, what's the number? Question 3, part 2. So a robot is programmed to travel along this curve C. Given that its y coordinate is increasing at a constant rate of 0.5 units per second, find the corresponding exact rate of change of its x coordinate when u is equal to 2. Exact just means cannot use calculator. Rate of change of its x coordinate. So in other words, what is it trying to find? Dx by dt equals question mark when u is equal to 2. Given what? Given what else is given?
The dy dt.
Yes, equals
The 0.5.
negative or positive?
Positive.
Why positive?
Because it's increasing, yeah.
Correct. If they tell you decreasing, which we'll deal with later in the next question, you have to put an extra negative sign on your own. Clear?
Yeah.
Okay, good. Next, move on. So dy by dt is equal to 0.5. What do you want to find? You want to find dx by dt, right? So I think we already know dy by dx is the same as dy by dt. Right? This one is legitimately a t, not a careless mistake I made. So that means that I can make dy by dt the subject. dx by dt. I want to solve for dx by dt. So dx by dt is nothing but dy by dt divided by dy by dx. Yes?
Yeah.
This one and this one swap around. Maybe I color code. Blue, go here. Yellow, go there. Can? Okay. Well, this is when u is equal to 2. So let's consider when u is equal to 2, what happens to your dy by dt? A notation that you can write for this is draw a vertical line, u equals 2. So let's take a look. Let's see. Oh, wait, it's a constant. So it doesn't matter what u is. It's always 0.5. All right? They give it to you?
Yeah.
That's what constant means. Doesn't matter what u is. How about your other guy? Your, what is it, dy by dx? Oh, by the way, I'm choosing these two fellows is because of the fraction here, the numerator and the denominator. I'm trying to solve the fraction. So dy by dx when u is equal to 2, what would it be? So you go back to the equation, or if you are not able to show the first part, the show that dy by dx equals to 1 over whatever, then just make use of the formula now. 1 over u power u plus 1. So 2 power 2 plus 1. Bracket 1 plus ln 2. Can? Okay, type in the calculator. 1 over 2 plus 1 is, oh, sorry, you cannot use calculator for this question. 2 plus 1 is 3, 2 power 3 is 8. 8 times 1 plus 1, 2. I'll keep it factored. It's fine. Then now I can sub in. So dy by dt is 0.5. dy by dx is 1 over 8 times 1 plus ln 2. 1 over, so that means this one can go up. You're left with 0.5 multiplied by 8 bracket 1 plus ln 2. Is this part okay?
Yeah. Okay.
And okay, good. Then 0.5 times 8 is just half times 8, which is 4 bracket 1 plus ln 2. Answer. And
Okay.
maybe I should also label here when u equals to 2. When u is equal to 2, so that means I know that I'm substituting u equals to 2 in each of these scenarios. Okay, Ken, that is the question. What is it? Question 3 done. Let's move on. Question 4. So question 4, tropical island. Don't care about what is that nesting pairs of fancy terms. Just think of them as nesting pairs of birds. You start off with 100 pairs, and we're counting the number of pairs. N refers to the number of pairs. In the first year, the number increases by 8. One theory suggested that the number n of nesting pairs after t years would satisfy the differential equation, blah, blah, blah. So they never ask you to set up the equation, they just give it to you straight away. Part 1, they want you to show that when n is equal to 100, the rate of increase of n is 8 per year. How do you do that? So what you do is you sub n equals to 100. Maybe I should copy down the equation first. So we are on the same page.
So I sub it into the dn over dt.
Correct. Yes. Then you will get, okay, I should write this down in a full sentence, into dn dt. Then you get dn dt equals to 1 over 5,000 multiplied by 100 multiplied by 500 minus 100 is 400. Then you can just type in a calculator. I think you will get your 8. Is it?
Yeah.
Divide by 5,000. Yep, correct. So equals to 8. Shown, done. Easy. 1 mark. Next, part 2. Describe and interpret what happens as n approaches 500. This one a little bit challenging. As n approaches 500 means it's getting closer and closer to 500. What happens to this fellow here? 500 minus n?
It becomes like 0.
Yeah, so you will write down arrow 0. It goes closer and closer to 0. Then what do you, if this is like 1 over 5,000 times n times 500 minus n, if this guy goes to 0, what happens to the entire thing?
Everything becomes 0.
Exactly. So dn by dt, which is equal to, copy down, it approaches 0. Yeah, that's all. Or in other words, interpret, right? So we must write the story. So you can say, as the number of pairs approach 500, the population tends towards 0, tends to 0, or they are going to go extinct. And
Okay.
number of nesting pairs, population, number of nesting pairs. If you really wanted to, you can write down number of nesting pairs of, what do you call it? Fancy terns. I don't know what is a fancy tern. I don't care. Whatever. I just think of them as birds. I didn't try to Google it. Okay, next, part 3. Show that the differential equation can be expressed in the form of dt over dn equals to 10 over n plus 10 over 500 minus n. This is a very creative question because it's not common. Do you notice that dt over dn, it looks very familiar? What is this?
Familiar?
It doesn't look familiar?
It's the opposite of the thing. Yeah.
Just flip around, right?
Yeah.
So that means, if let me just rewrite it as a fraction, so it's easier to flip it. N times 500 minus n over 5,000 is your dn by dt. So what does it mean about dt by dn?
It's the inverse.
Exactly. It's just the inverse. So flip the fraction around. So it's really just 5,000 over n times 500 minus n. Is that okay?
Yeah.
Can, right? You see n times 500 minus n. What do you think you want to do now? you look at the question, got two smaller fractions.
Oh, can split up.
Partial fractions, right? That's the name.
Mm.
Exactly. So that's what we're going to do. So now we're going to let this fella here equal to a over n plus b over 500 minus n. Right?
Yeah.
So that means, okay, maybe I should just write the working below. Then just solve. So 5,000 is equal to a times 500 minus n plus b times 500. Okay, then I can say sub n equals to 500. What do I get? 5,000 remains equals to 500 minus 500. You're left with 0. 0 times a is 0, so I ignore it. I'm left with b times 500, 500b, which implies that b is equal to 10. If I sub in n equals to, let's say, did I do it wrongly? Oh, this should be an n, huh? Correct?
Yeah.
Yeah, okay. Sorry about that. Yeah, so now we sub in n equal to 0. What do we get? 5,000 equals to a times 500 minus 0, which is 500a. And then if you sub in this n with 0, you get 0 times b, which is plus 0. So you can ignore it. Then you can solve for a now, also 10. 500 times 10 is 5,000. Yes?
Yeah.
Okay, good. So therefore, you conclude this, therefore, must be equal to 10 over n plus 10 over 500 minus n. Is that right?
Yeah.
Yes, huh? Okay, good. Shown. And solve the equation given that n equals to 100 when t equals to 0 from the question. So now we solve. Take a look. Is this separable or is this normal differential equation?
Normal.
Normal. Don't go and divide over. So dt by dn. Oh, sorry. You can just solve for what? Do you solve for n or do you solve for t? After integrating.
So for n.
Would
No. So for t.
it be simpler if I change the t to a y and the n to a x?
Oh, yeah, right.
Right? Same thing, right?
It's the y. Yeah.
So we must learn the on top variable is the dependent one. The bottom is the independent. We always solve for the dependent variable, which is in this case the on top one, which is t. Okay, so solve for
Okay.
t. Solving for t, we get integrate 10 over n plus 10 over 500 minus n. What's the variable? X, t, or n?
N.
Very good. Yes. You see, the analogy is independent variable x. Then you integrate with respect to x. Right? So here is now changed from x to n. Okay, carrying on. This just becomes 10 of ln modulus n plus 10 times ln of 500 minus n. Can you spot my mistake? This is correct. This is correct. Here is wrong. Where's the mistake?
Is it the 10 ln 500 minus n?
Correct. What should it be?
Negative. It should be minus.
Very good. Yes, because of the minus over here, this shouldn't be a plus anymore. It should change to a minus. Well done. Okay, you spotted my mistake. Then please spot your own mistake next time.
Okay.
Okay, good. Then now you got t equals to whatever. What the question asks? Given that n equals 100 when t equals 0. Okay, so just sub in the initial condition. Sub n equals 100, t equals to 0. So you get 0 equals 10 ln 100 minus 10 ln 500 minus 100 is 400. Modulus 400 is still 400, so don't need to write. Plus c. Then you can solve for c. C equals, let me see. So 10 ln 400 minus 10 ln 100. Correct? Good. Factor out 10. Actually, don't need. You can just leave it. But if you want, you can factor out 10, then you get ln 400 minus ln 100, which means that you can clean up, use logarithm rules to become 400 over 100, which becomes ln4. Okay, not important. At the end of the day, we can sub the C back in, then we can just get our answer. No space. Okay, T equals to the C you sub in with 10 ln 4. Don't forget a plus. Then that's our answer. Okay, this one. Okay, good. Next. Question 2019, extra question. Now I decided to prepare some extra question from the TYS. Let's take a look at this one. So what we have scientists, this is from 2019. It's investigating how the temperature of water changes in various environments. The scientist begins by investigating how hot water cools. Okay. Can you give me 30 seconds? I need to get the charger.
Okay, sure.
Hold on. Mic test, can you hear me?
Yeah, okay.
Okay. Hold on.
Okay.
Charger, where are you? Okay, I found my charger. Good. Mute this. Share screen. Go back. Loading. Okay, can you see my share screen?
Yeah, okay.
Okay, good. Let's continue then. So yeah, scientists investigating how hot water cools. So okay. Yeah, just continue. Let's read the story. So water is heated in a container and then placed in a room, a cool room. So it's cooler compared to the water, hot water put in a cold room or just normal room temperature room. And it's kept at a constant temperature of 16 degrees Celsius. So it's a 16 degrees Celsius room. The temperature of the water T minutes after it is placed in the room is theta degrees Celsius. This temperature decreases at a rate proportional to the difference between the temperature of the water and the temperature of the room. So far, okay?
Yeah.
Okay. The temperature of the water falls from a value of 80 degrees Celsius to 32 degrees Celsius in the first 30 minutes. Part A, write down a differential equation for this situation. Solve this differential equation to get theta as an exact function of T. How? You got tried before?
Yeah, but I forgot already, like the answer. Yeah.
Okay. Technique is always figure out what is your dependent variable, what's your independent variable. You should read this part, Solve theta as an exact function of T. So what's my dependent?
The theta degrees.
As a dependent, and what's independent?
The T.
Exactly. So what do you want? D what over D what?
The d theta over dt.
That's a start. Then now you must remember it's always what minus what?
The rate increase minus rate decrease.
Yeah, okay. I like to just memorize in and out, but you get the idea. There's a plus and then there's a minus, or increase and decrease if you want to be more precise. Can. Let's draw an arrow, can already. You don't need to write this down, by the way. This is just keep at the back of your mind, and then you just fill in with the actual formula. So let's think about it. What's keeping it what's making it heat up? Think about a situation. You heat up water, so it's very, very hot already, 90 degrees Celsius. Then you bring it to a room that's 16 degrees Celsius. Do you think the water will heat up?
No.
No, right? So therefore, this component
No
here is a
rate up.
soft.
Yeah.
But there is still a minus sign. So be careful, must have a minus sign. Then what's the rate of decrease? What did they tell you?
Proportional to the difference between the temperature and the room, temperature of the water in the room.
Temperature of water, temperature of the room. So proportional to, they say proportional to means directly proportional to. So you must always have a what?
Kx.
K, x. But now in this case, if that's only if it's proportional to x. Here, what is your x?
Kt.
No, read the question. Rate proportional to, maybe I should underline it more carefully. Rate is referring to d theta by dt. Proportional to is telling you it must be k times something. Maybe
Is
I
it
should write
like
down.
theta minus the 16?
Very good, exactly it is. Yes, theta minus, what is it? Let's read. Difference between temperature of the water and the temperature of the room. What's the room temperature?
16 degrees.
Exactly. So it's minus 16. Yes, correct. See, you can set up already. Yes. Just read carefully. You must translate the English into the math. Not that bad, right? I hope.
Yeah.
You practice a lot of questions already. Okay,
Okay.
can. Then the next part, they tell you temperature of the water falls from a value of 80 to 32 in the first 30 minutes. So this is really just the initial condition, okay? Can you tell me what's the initial condition from this?
80 degrees. When theta is 0, then
Wait, what is 0? Say again.
when the t is 0, then the
t is 0.
is 80.
Yes, correct. Because you start at 80 degrees Celsius. Then when t is equals to what? Theta is equals to 32. Yes, 30 minutes later. Okay, good. Then you have all the equation to solve already, right? So this should be not that bad, right?
Yeah.
Here I write down water won't heat up, so that's why I cancel off cross. Okay, good. So now we can work with it. So here is d theta by dt. How come it's missing? What happened? Oh, okay. Yeah. So anyways, d theta over dt equal negative k times theta minus 16. So you can identify that there's theta here. So it's a what kind of equation?
Mass separable.
Must separate them. Separate the constant of the x from the variable. So bring down. Then you're left with theta minus 16. And then you have a k, negative k left behind. Then I just integrate both. Maybe I show you what I'm doing. I'm skipping a few steps. I add in one more line. What I'm doing is I'm dividing first. So everything else stay the same. Then maybe it's better if I use a different color. I integrate with respect to t. Integrate with respect to t. Why t? Because here. Why did I choose to use the letter t? Because of the independent variable here. Okay, so now you realize the t cancel off. You're left with integrating 1 over theta minus 16 d theta. And then you're left with integrating negative k dt. So continuing on, I think you know how to do this already, right? So ln modulus, negative k, just bring in an extra t plus c. Take note, it's not x, okay? This is t. This is t, not x. I have to keep on emphasizing this. It is not x. It is also not theta. Follow the letter. Follow the independent variable.
Okay.
Anyways, carrying on. Now, what did I do? What did I do? Let me see. Oh, I have to restart. I think I did something wrongly. Let's just do it. So you got ln of modulus theta minus 16 equals to minus kt plus c. So how do you notice that there's a single ln already? So can just bring over. Then you just get e power negative kt plus c. Simplify a bit, it becomes times e power c. Simplify a bit more, bring the e power c to the left. Then you open up the modulus, so it becomes a plus minus e power c times e power negative kt. But wait a minute, this one is just a constant, right? This part here. So you can just call it a times e power negative kt, theta minus 16. Then you can solve for theta. Theta will be equal to 16 plus AE power negative KT. But we are not done yet. Now we need to solve for A, solve for K. Why do you think there are two? So, okay, when you see two unknown constants, how many initial conditions do you need?
Two.
Two, which was over here. 1, 2, correct? Okay, good. So we'll just do that. So sub in from I choose to sub in t equals 0 and theta equal to 80. Here's what I get. 80 equals to 16. Sorry, I made a mistake here. It should be a plus. Plus a times e to the power of negative k times t. T is 0, so negative k times 0 is just 0. So that's why I have a 0 here. Then anything power 0 is 1, so a times 1 is just a. Sorry, it should be a plus here. I'm just going to redo the whole thing. Okay, so what you get is 80 equals 16 plus a, so a equals to, if I'm not wrong, 64. Therefore, theta equals to 16 plus 64 e power negative kt. I replace the a with 64. So, can? Okay, good. So that is negative kt. Not done yet. Still got unknown k. Still got unknown k. How to solve for k?
Start again.
Start again, exactly. Oh, I didn't write down working. Okay, so now use what's the other condition? T equals to 30.
0 and 32. 0 and 80.
0, 80 used already.
The 30 and 32.
Yes. So you use the other condition. 30 and 32. Let me just copy this down in case I forget. Okay, so I copy and then I paste. Oh, t equals to 30, theta equals to 32. Very good. So now I can sub in into the updated equation. 32 equals to 16 plus 64 multiplied by e to the power of negative k times 30. 32 minus 16, I get 16. 16 I bring over. You get 64 times e to the power of negative 30k. Here I divide by 64. 16 over 64 is 1 over 4.
Oh.
Right?
Yeah.
You're left with e to the power of negative k times 30. You got a power. You got an e. What should you do?
Change to ln, like ln both sides.
So we got ln 1/4 equals ln e power negative k times 30. ln and e will cancel off. You're left with
negative 30k.
Good. Solving for k. ln 1/4 over negative 30. Can?
Can.
Okay, good. So let's see how I can clean up. Maybe I can clean up a little bit. This is extra already. Don't need. Actually, forget it. Never mind. Don't waste time. Just sub back in directly into the equation. Therefore, theta equals to 16 plus 64 times e to the negative k times t. Then you just copy and paste. During exam condition, they cannot fault you. This is correct. You don't need to clean up. If you really wanted to, you can clean up. ln 1 over 4 divided by negative 30. Okay, actually, you don't need. Negative and negative will cancel off. So it becomes a positive. So I'll just deal with the positive case. ln 1 over 4, maybe you can rewrite as ln 4 power negative 1. Okay, how come change to red pen? Right? Then negative 1 power, you can just bring down. So what you get? Negative ln 4 over 30. Also not much difference. You just put in an extra minus sign. Not much difference. Okay, so don't bother. Just leave it. That's your answer. Okay. Good. That is your part A. Okay, now you want to find part B. Find the temperature of the water 45 minutes after it is placed in the room. So this is really telling you 45 minutes T equals 45. Here, find temperature. So theta is the one you want to find. Make sense?
Yeah.
So all you need to do is sub T equals 45. Solve for theta. That's a symbol, theta. Okay? Can? Good. So we go to the, I need a new page. Hold on. So we go to the equation again. We got theta equals to whatever. Part B. What's the question already? I cannot remember. Whatever. Doesn't matter. So they tell you sub t equals to how many minutes again? Forget. Memory very weak. Let me just copy the question down. Oh, what's this? Okay. Never mind. 45, right? 45. Okay, so we get theta equals to 16 plus 64 multiplied by e to the power of what's this? ln 1/4 over 30 times 45. Here, they never ask for exact answer, right? So never mind. We just type in the calculator straight away. 16 plus 64. If they did ask for exact answer, then you have to work harder, huh? But for now, don't need. ln 1/4 times 45 over 30. Wow, coincidentally, it's a exact number 24. Do you want me to show you how to get this exact answer manually?
Yeah.
Can I? Okay, I'll do that. Don't need to. This one just 1 mark.
Oh, okay.
Just extra only. Okay, 45 over 30 is what? 3 over 2, right?
1.5, yeah.
1.5, 3 over 2, right? So ln 1/4 times 3 over 2. Okay, what I'm going to do now is I'm going to rewrite it as it's it's multiply. Oh, that's not good. Okay, here I will rewrite it like this. 16 plus 64. I'm gonna put it below a bit. I need more space. Times e to the ln of 1/4 bracket 3 over 2. Okay, so this times 3 over 2 means this entire thing is raised to the power of 3 over 2. But look within the brackets, what do you see? E and ln. What happens?
Cancel out.
You're left with 16 plus 64 multiplied by just 1/4 to the power of 3 over 2. What is 1/4 to the power of 3 over 2? Let's work it out at the side. 1/4 power 3 over 2 is just 1 over 2 square, right? Then power 3 over 2. Correct or not? 1/4 is half square.
Yeah, correct.
So that means 2 can cancel off now. Then you're left with half power 3, which is 1 power 3, 1, 2 power 3, 8. Yes?
Yeah.
Then you're left with 16 plus 64 times 1 over 8. I think this one, 64 divided by 8 can do manually already. 16 plus 8, then you get 24.
Okay.
Oh, can? Yeah, 8 times 8 is 64. I'm sure you know that.
Yeah.
Okay, so theta equals 24. Or if you want to be more precise, 24 degrees Celsius. Okay, that is part 1 done. Let's move on to the next part. Cut this, bring down, paste it here. We can do the question. What was it? It's part 2. Question part 2. So now the scientists, they decide to deal with a different scenario. Now they don't look at water, they look at thickness of ice on a pond. Thickness of ice on a pond. Then my pond looks like a petri dish. Sorry for my bad art. Okay, so you model the thickness of ice on a pond. So in winter, the surface of the water in a pond, it freezes. Once the thickness of the ice reaches 3 cm, it is safe to skate on the ice. Be careful of this, 3 cm. They don't tell you for fun. You need to know what is the tree representing later. So continue reading. The thickness of the ice is T cm. So now you know T equals to 3. Here, right? T minutes after the little t, T minutes after the water starts to freeze. The freezing of the water is modeled by a differential equation in which the rate of change of the thickness of the ice is inversely proportional to its thickness. Given that capital T equals 0 when T equals 0, after 60 minutes, the ice is 1 cm thick. It is given that something, it is given that T equals 0 when T equals 0. That's your first pair of initial conditions. After 60 minutes, ice is 1 cm thick. That's your second initial condition. Okay? Okay, in addition to T equal to 3. So let's think about it. What is the differential equation? D what over D what?
D big T over small t.
Very good. What did they tell you about this rate?
It's inversely proportional.
Rate, sorry, yellow color a bit difficult to see. Rate is of the thickness of the ice, which is capital T, inversely proportional to thickness. So K
over
thickness
T,
is what letter?
the big
Thickness
T.
is big T. Thickness again, big T again. So T again. Okay. Yeah, that's it. That's all.
Oh,
Yeah. Easy, right? Easy, good. 6 marks. Wow, 3 marks. I hope you can get this 3 marks.
yeah, because it looks too simple to be true.
No, it's quite simple one. Really. Yeah, so that's all. K over T. Then after that, how to solve? Is this separable or is it normal?
This one need to separate.
Need to separate. So here the T, right? Over T. So bring over. Does it become times or divide?
Becomes like T because it's 1 over T, so it's T.
Yes, correct. Or just think of it as multiplying by T on both sides. Yeah, the T will cancel off. Oops. Yeah, okay, then T times dt over dt equals to K over T. Oh, sorry, no more T, just K. Integrate dt. Integrate dt. dt cancel. Integrate T dt. Oh, say T so many times. I hope you're following.
Yeah.
Then integrate T dt, you get, what is it? How to do this?
Is it T squared over 2?
Correct. Okay, then the right hand side becomes K times T plus C. Okay, we're not done yet. Still got the unknown K, unknown C. 2 unknowns. How many initial conditions do you need?
2.
How many do we have?
2.
Okay, so the question never said wrongly. Okay. Yeah, so but you should expect this. You should expect that you see 2 unknowns, you get 2 initial conditions. So that's what we're going to use. Let's see. Given that capital T equals 0 when little t is equal to 0. So we're gonna sub T equals 0, T equals 0. What do we get? 0 square over 2, 0. K times 0, 0 plus C. This implies that C equals
0.
Exactly. So now we can simplify the equation to T square over 2. Maybe I should be more precise. I'll call this equation 1. And then I'll say sub into 1. If you never write, I don't think they will fault you. It's quite obvious. Then here you can also say sub C equals 0 to 1. So you get T square over 2 equals to KT plus 0. Call this equation 2. Then what do we do next? What's the next condition? Sub
60. Like
what
small t.
Little t
big
equals
T equals to 1, then small t 60.
Very good. Yes. Into 2. So what we get is 1 square over 2 equals to K times 60. Solving, you get K equals to 1 over 120, right?
Yeah.
So that means that you will get T square over 2 equals to 1 over 120 times T. I'll just put the T on top. What did they ask for? Find the time from when freezing commences until the ice is first safe to skate on. What does that mean?
So the big T should be 3.
Sorry, big T should be 3. Yeah, correct. Here, because they asked you thickness become 3 cm, then it's safe to skate, right? So sub in capital T equal to 3, then you solve for little t, right? The other variable, there's only 2 variables. Can understand the question? So they never tell you capital T equal to 3 anywhere during this sentence. You need to deduce on your own from the initial part of the question. They like to confuse you. They call this application. Yeah, until the ice is first safe to skate on, means capital T equal to 3. Okay, so now we're gonna do that. No space. Okay, I'm gonna squeeze the working here. So now sub T equals to 3. First safe to skate on. First point in time when it's safe to skate on. So now you get 3 square over 2 equals to T over 120. Simplify, 3 square is 9 over 2. Then 9 over 2 equals T over 120. Maybe I rewrite it like this. T over 120 equals 9 over 2. Then times 120. So 540. Can?
Can.
Okay, good. So yeah, that's all for this question. Not that bad, huh? I hope.
Yeah.
Okay, next question, next example. This is from 2020. Okay. Let's read the question. Another scientist again. So maybe maybe it's a scientist question again for your I don't know. So scientists, they are investigating the effect of disease on the number of sheep on a small island. So now population of sheep. They discover that every year the death rate of the sheep is greater than the birth rate of the sheep. So they are slowly dying. The difference every year between the death rate and the birth rate for the population of the sheep on the island is 3%. The number of sheep on the island is P at the time T years after the scientists begin observation. Part 1, write down differential equation. So take note, this is part 1 and part 2 is one scenario. Later, part 3 onwards is a different scenario. Okay, let's just deal with part 1. So here, current situation, you know you must have rate in minus rate out, correct?
Yeah.
But what's the ratio? I mean, D what over D what? What's the dependent variable? What's the
P.
From here and here you can tell. So you need dP over dt. Can you tell me what is rate in, what's rate out? Trick question.
I think cannot tell.
Cannot tell, right? But you cannot tell them individually. But what can you tell?
The difference is 3 over 100.
Yes, correct. Because they already tell you difference is 3 over 100. So it's really just this entire thing, not the individual parts, but the entire thing. They gave it to you. So it's actually, in a sense, easier. So it's really just 3%. 3% of what?
3% of P.
3% of $1,000? No, not $1,000. It's the population of sheep. So P, right? So it's really just 3% times P. But wait, you tell you that disease, death rate greater than birth rate. So do you think this should be positive or should it be negative?
Negative.
Exactly. You need to think of this on your own. Death rate greater, introduce the negative sign. Introduce yourself. They won't tell you, they will tell you very indirectly. Oh, death rate is greater than birth rate. Oh, then you know they are dying. So it must be decreasing rate of change. So must have a minus sign. This one must deduce on your own. Is that okay?
Yeah.
So 3% times P. Yeah, simplifying, I prefer a fraction like this. So negative 3 over 100P. Can?
Can.
Okay, yeah. So part 1, let's go. So D population over dt time is equal to negative, because they are dying, 3 over 100p. Solve. Sorry, that's part 1. Done already. Free 2 marks. 2 marks. Okay, part 2. Solve this differential equation to find an expression for p in terms of t. Explain what happens to the number of sheep if this situation continues over many years. Later, then we do with the over many years. Now just standard procedure, solve for p. How? P here, separable or normal?
This one is separable.
Separable, right? Definitely. So P bring over. Now there are 2 options. You can either, option number 1 is like this. You times 100 over negative 3P. You might want to do this, right? Integrate dt. I don't prefer this. I don't like. Because here, wow, very scary. 100 over negative 3, very scary. What I prefer instead, it's not wrong. Okay, sorry, I shouldn't put down a cross. I should say it's correct but slow. I prefer this. Just divide by P. Then leave the constant alone, -3 over 100.
Okay.
Prefer this. Okay, faster.
Yeah.
How? Let's see. Integrate dt. Integrate dt. This one very easy to integrate. This one need to factor out 100 over -3. Need to think a little bit. Not so good. You may get confused. So ln of. Okay, tell me what ln of what?
Ln of modulus p.
Very good. I'm waiting for you to say modulus. Okay, can you remember? Well done. Carry on. So now integrate -3 over 100. What do you get?
-3 over 100 t.
Very good. Not x, Not x, Can, t.
Yeah.
Good. What's missing?
Plus c.
Very good. Yes. Then carry on. Tell me.
So now I can e both sides.
Okay. What do I get?
So I get modulus p equals to e to the power of -3 over 100. Then I can
Don't complete the sentence. Don't just say -3 over 100.
-3 over 100 t. Then I can times e c to the power of c. Then I put plus minus. So
Wait.
equals,
Sorry. You must tell me the full sentence. Don't just plus minus.
okay. P equals to plus minus e c times e -3 over 100 t. So A equals to plus minus EC.
Let A equals to plus minus EC first. Good. So A times the rest. Yes?
Yeah.
Okay, good. Pause. Let's read the question. Here, they never give you initial condition. Do you notice that?
Yeah.
So you don't know what is your A, and you don't know what is your A, that's the only variable. So it's still okay. Why? Because let's read the question. What they ask?
You say over many years.
What does that mean about T?
So T is like tending to infinity.
Yes,
like very
correct.
large.
Very, very big. Okay, let's look at the equation. So number of sheep they're asking about P. So P equals to what when T goes to infinity? That's the question. Okay, so let's look at the graph. Let's look at this. It doesn't matter what A is. You can just draw a few graphs on your GC. If let's say A equals to 1, example. Here's how the graph will look. It will look something like this. If A equals to -1, this doesn't make sense because it means your graph will look like this. It will become negative, which means your population is negative. How can you have negative number of sheep? You're counting them backwards. Doesn't make sense,
Yeah.
No. So this doesn't exist. A must be more than 0. From here, from the obvious, you can deduce that. So basically, the graph will always look like this, no matter what positive value of A you give. It will always go downwards because of the negative here. Please remember, y equals to e power x exponential positive x. The graph looks like this. Intersect at 0, 1. And of course, it's this one is extra already, not relevant, but it's not exactly relevant for now. But same topic. The ln graph looks like this. Can? Please remember, this is from Amex. Then how about e power -x?
So it looks like the ln x graph.
No.
Oh.
X go to -x. What's the graphical transformation method?
Like it reflects about the y-axis.
Yeah, so it actually looks like this, right? Right, red color like this, reflect, become like this. About the satay stick here. Can?
Can.
So what do you notice about the graph? It's going towards
0.
Yeah, so that means it's not actually y, it's not actually y here, it's p, right? So it's p axis against t. So that means your p is going towards
0.
Then now, so you got the idea already. Population is dropping to 0, means they're going to die. But you must phrase it nicely. As time goes on to, I don't know, infinity, the population tends to 0. Okay. Sheep population eventually, just phrase it somehow, eventually dies off. No more. Gone. Okay, extinct.
Okay.
You can just work on your English, I don't know. But here's the standard way to describe it. Tends to 0 or tends to infinity. Okay? I like to use these 3 words. Okay, that is this question. Move on. Is it okay? Do you need to rush off?
I don't.
Okay, can. Let's go on. So the scientists import sheep at a constant uniform rate of n sheep per year. Difference every year between death rate and birth rate remains at 3%. So this is now a new situation. So what the scientists realize is that, oh no, the sheep is going to die, e power negative x, negative t, e power negative 300, 3 over 100t. So they want to salvage the situation. So they bring in more sheep. Okay, see, they import more sheep because they know there's not enough. Oh, so that's why now you got a new rate in and a rate out. Sorry, my handwriting. Let me try again. RATE. Can you tell? Of course, the ratio is still dp by dt. But can you tell me what's the rate in and what's the rate out now?
The rate in is n.
Very good, because they told you constant uniform rate of n. So n here. Then what's your rate out?
I don't know.
Maybe it's better if I rephrased it like this from the previous one. I put a 0 there. 0 minus 3% times p. This was the original condition. 0 and 3% times p.
Also, it's 3 like minus 3 over 100p.
Yes, exactly. That's why they tell you remains means exactly the same, still the same, 3 over 100p. Okay? That's your rate out, lor.
Okay.
That's all. You change the 0 to n. That's all.
Oh.
Okay. Then after that, write down differential equation to model the new situation. Wow, another free 2 marks. So easy. Change 0 to n, you get 2 marks. Okay. But testing your understanding. So yeah. So I'm just going to copy and paste my part 1 answer so I can write less. Part 3 is now looking at a new scenario where instead of just minus 3 over 100p, the scientists make sure to import more sheep, so it's n. Okay. So that is part 3 done. Free 2 marks. Ding. Okay, part 4. Let's read part 4. Solve the differential equation to find an expression for p in terms of t and n. So they purposely never tell you what's n. So you still need to keep it as an unknown. All right, so just solve. Solve part 4. Let's go. How to solve? Can you tell me what is this? Separable or normal?
Separate.
Separate. But here, let me ask you, can I just do this? Can I do this? 3 over, I see minus 3 over 100p, so I bring over. Like this, 3 over 100. So positive 3 over 100p plus dp by dt. Equals to n. Can I do this?
Cannot.
Why cannot? I bring the p over already, ma. What's wrong?
It's not divide.
No, the key thing here is this sign here. Every time we get p, right, it's something like 1 over p times dp by dt. Then we on the left hand side, then the dt cancel off. Your left with integral 1 over p dp. Right? Here, what you notice is that it's multiplication. Yes, correct. And now cannot cancel as well. So the key thing is you need multiplication over here. Okay, you must have multiplication. Here, what I just did was addition, not times. Cannot cancel dt away. Let me show you. What I mean is, I want to integrate this guy with respect to dt, but the dt cannot disappear. Let's see how. Maybe I can split it up. Okay, so if I want to color code it, I need to do this. Let me just add a dt here and an integral here. Yeah, so basically integrate term by term. This part dt can cancel. Correct. You're integrating 1 with respect to p. But here, this part cannot. P and t, different variable, you cannot solve. So that's why plus over is not a good idea. So this does not work. Bad. Don't bring over. Don't just minus bring over. Wrong. So what should you do instead? Let's see. what you should do is to make sure that on the right-hand side, here you got two terms, right? Always make it one single term. Do you know what's a term?
Yeah. The N
1,
and
2.
C.
Got plus minus, that's the key that separates term. So what you should do now is to combine into a single term. Combine into one term. Let's see. So add fraction, n is just this one, there's a over 100, right? So maybe I can rewrite it neatly as 100n over 100 minus away 3p over 100. Combining, I get 100n minus 3p divided by 100. Agree?
Yeah.
Then you can either take the entire fraction over, or you can be a little bit smarter. Here there's an over 100. So don't you agree with me that it's really just 1 over 100 multiplied by 100n minus 3p?
Yeah.
So what should I bring over?
I bring over the 100n minus 3p.
Just this part, right? Bring
Yeah.
over. In other words, you're dividing. So that means you're left with 1 over 100n minus 3p. Multiply by dp by dt equals to 1 over 100. Then standard procedure, I think you know how to proceed already.
Yeah.
So the trick here is combine into one term. Then divide. Never plus or minus. Not plus, not minus. Okay, then divide. Divide by what? Here in this case, I divided by, maybe I should write down, divide by 100n minus 3p. You don't need to write this divide by whatever during exam. No time, no time. Just do it. Just do it. Okay? The conclusion is more important than writing this down. Okay? Yeah, this one don't need, just think inside your head can already. I'm just writing notes for you in case you need to revise and you forget. Okay, so carrying on, dt cancel off. Yay, very good. Now I can try to integrate this. Integrate 1 over 100n minus 3p with respect to p. How? 1 over 100, I think you should know is 1 over 100t. What's missing?
The plus e.
Okay, good. Okay, then we deal with the left-hand side now. How?
Can
1
split up.
over split up. No. Maybe it's easier if I give you a smaller number. 100n is just a number, right? So it's really just let's say 5. And instead of p, maybe I put x. How do you do this one? 1 over.
Oh, it's just negative ln 5 minus.
Slowly?
3. Negative 3 ln then modulus 5 minus 3x.
Wrong. Almost. It's not negative 3. You don't times negative 3. What should you do instead?
Negative 1/3.
Yes, divide by negative 3. 1 over negative 3. Please remember that. How do you check that you integrate correctly? You differentiate and you work forward. Okay, so let's see. If you try to differentiate 1 over negative 3 ln of 5 minus 3x, what do you get? Factor out 1 over negative 3. Multiply by d by dx of the ln. Let's just pretend that the modulus is not there. If not, it's very difficult to differentiate. Just call it round bracket. Then differentiate 5 minus 3x, what do you get? I mean, differentiate ln, what do you get? You get 1 over. Right? But then chain rule tells you what? You must differentiate the inside. The thing inside the bracket as well.
So negative 3.
0 minus 3. Exactly. Then what happens when you have 1 over negative 3 and positive negative? And what happens when you have times negative 3 and divide by negative 3? Cancel off.
Out. Yeah.
Then you get back to 1 over 5 minus 3x. So that's why you need the divide. Is to make sure you get rid of the minus 3 because of chain rule. Inverse chain rule. Inverse chain rule. Here is because of chain rule. Here is it's like an antidote. The chain rule is like a poison. You can think of it like a poison. And here is like an antidote to cancel away, neutralize. If you study chemistry, acid base, right? This one acid, this one is base. OH minus cancel with the H plus. And you get back the original. So that's why you must have divide. And you must remember, differentiation must have multiply because of chain rule. So integration must have divide. the opposite, the yin and the yang, the black and the white, the opposite of times is divide. Divide by -3. Okay, integration is the opposite of differentiation, so everything also opposite. Instead of multiply for chain rule, you have divide. Can understand? Can you remember?
Can.
Can divide by -3. Okay, move it away. Can go back to the actual question. So now how? How now, cow bro?
Oh. So it is
ln modulus
100n minus 3p. So
inside. But
yeah. So
but
yeah, the one in front. Yeah, negative.
read
One.
it out. Read it out. 1 over.
1 over -3.
Very good. Yes. Can please remember this. ln will give you 1 over. 1 over integrate will give you ln. Then make sure you divide by the coefficient of the variable. Okay. Good. It will always be linear. They will never give you something more complicated than a linear one. Usually, I think. Okay, can then just copy down the right hand side. Then solve. -3 you bring over first. So you get what? Left hand side ln whatever equals to -3 over 100 minus, oh, don't forget the t, sorry. Oh, my t and plus look the same, sorry. Plus, oh, sorry, -3c, so minus 3c. Okay. ln is a single ln already, so you don't need to use any logarithm rule. You can just bring over straight away. It becomes e power -3, handwriting, -3 over 100 t times e power -3c. Can?
Can.
I'm gonna swap them around to make it look nice. Like this, e power -3c in front. Open up the modulus. So get plus minus e power -3c, e power -3 over 100t. What do you do? Let a equal?
Let a equals to -e to the power of -3c.
Plus minus, right?
Yeah.
E power -3c. Okay. A, e -3 over 100t. 100n minus 3p remains. What did the question ask for? Let me read the question. I forgot. Write down, solve the differential equation, find expression for p in terms of t and n. Also solve for p lah. Make p the subject. Okay, let's just do that. Make p the subject. How? How? Tell me.
200n plus a e to the power of -3 over 100t equals to 3p.
Do you say 100n plus or minus?
I say 100n minus.
Minus ae. Okay, can. Equals to positive 3p. Correct?
Yeah.
Can
Yeah,
okay.
Then divide by 3 on both sides.
Okay, correct. Yes, I'll just do it for you. So p equals to copy and paste this whole thing, then divide by 3. You can simplify a bit more. So 100 over 3. Don't need to rewrite as 33 and 1/3. No need. Mixed numbers are beyond. From A max onwards, you don't need to rewrite your answer as mixed numbers. We are all mature math students now. We know how to convert to mixed number using a calculator. We don't need you to show us that. Just relieve it as an improper fraction. It's easier. 100 over 3. Okay, much neater. Easier to manipulate also. A over 3 e power -3 over 100t. Okay, good. Let's read the question. Here, p in terms of t and n is fine. Then now let's move on to part V. Given that the number of sheep settles down to 500 after many years, find n. What does that mean? Let me just paste the question here.
The p tends to 500.
P tends to 500. So let's take a look. How can we make sure the p tends to 500? Oh, sorry. Sorry, what else? What else? After many years means what? T goes to what?
T tends to infinity.
Okay. So t also tends to infinity, this is the initial condition they gave us. It's not an equal sign, it's a limit. You don't need to know limits, but just need to know tends towards means it's a limit. It's going towards infinity. Let's take a look at this equation. Study it. What happens when t goes to infinity, meaning it goes to 100 or 1000, 10,000, become very, very big. What happens to e to the power of this guy?
It like tends to 0.
Tends towards 0, exactly. So as t goes towards infinity, this fella here goes towards, what is it again? 0. So what do you know about this second term here? Minus a over 3 times of 0.
So the entire thing tends to 0.
The second term, and not the entire thing, just the entire of the second term.
Yeah.
Yeah, I should highlight. Goes towards 0. Okay, or maybe it's better if I just copy and paste it here. So this tends towards 0. Okay, then what happens to your 100 over 3n? Nothing happens. It just stays there. But this pink color part becomes 0. So what are you left with? You're left with, on the right hand side, 100 over 3n minus 0. Okay?
Yeah.
Okay, but wait, what about the left hand side? What's p? As t goes to infinity, what happens to your p?
Tends to 500.
So maybe you don't need tends to any already. Just put equal straight away. So this becomes 500. Can see?
Can.
Then now you can solve for n. Correct or not? Minus 0 can ignore. N equals to 500 times 3 over 100. This gives you 15. Okay?
Can.
That's the answer. Done. Yay. Just nice. Okay, exceed by 10 minutes. Okay, that's all the questions I have. Do you... Okay, here, I will... Okay, let me start the recording first.